गुड आफ्टरनून, नमस्कार। आज के कार्यक्रम में आप सभी का स्वागत करता हूं। आज हम सबके लिए बहुत ही खुशी की बात है कि एक ऐसी पर्सनैलिटी हमारे साथ हैं जिनको सुनना किसी भी उत्सव से कम नहीं है और मेरा काम आज है कि उनको आपसे इंट्रोड्यूस कराता हूं। इट्स a matter of privilege, honor, pride and happiness to have an iconic and distinguished person like Dr. K. Kasturi Rangan, who will deliver a talk on reaching new heights in space Bharat's way. अंतरिक्ष में नव उड़ान भारतीय पथ. We all know Dr. Kasturi Rangan. He is an architect of new education policy, which has recently come. He was the chairman of the committee. Every scientist of India aspires to, dreams to become Dr. Kasturi Rangan. He was a former chairman of ISRO. For about 10 years, he was chairman of Indian Space Research Organization and recipient of highest civilian honors, Padma Shri in 1982, Padma Bhushan in 1992, Padma Vibhushan in 2000. And he has also awarded Shanti Swarup Bhatnagar Award in 1981. So it means what? He's an accomplished scientist and a great human being. We all are lucky to have a person like you on today's program. And on the topic is very near to his heart. And Dr. Kasturi Rangan completed his Bachelor of Science Honors and Master of Science in Physics from University of Bombay and received his doctorate in experimental high energy astronomy in 1971. As I have already told, he worked for 10 years as chairman of ISRO. Subsequently, he became the member of the upper house of Indian Parliament, that is Rajya Sabha, from 2003 to 2009, and concurrently the director of National Institute of Advanced Studies, Bangalore. Later on, he served in the Planning Commission also, Erstwhile Planning Commission from 2009 to 2014. He was also entrusted with the task of heading the Karnataka Knowledge Commission. He was also assigned by the central government, and he was chairman of so many prestigious committees of the Government of India and other government. He has served in different capacities. Dr. Kasturi Rangan is a member of several international and national academics, including being the fellow of all 4 major science and engineering academics of India. Among others, he is a member of the International Astronomical Union, fellow of the World Academy of Sciences, honorary fellow of Cardiff University, UK. His contribution in the development of India is immense. Dr. Kasturi Rangan has won several awards, including Brook Medals of International Society of Photogrammetry and Remote Sensing. So many awards, and but the best is what I say is the Shanti Swarup Bhatnagar Award, and various Padma awardees. We are very lucky to have a person, the eminent person like him today. I welcome you, sir, and I would like to request you to deliver the talk. And I am also happy to share this is the 50th talk of the program. So this is, we are very lucky to have a person like you. Thank you, sir. Over to Dr. Krishna Murthy for delivering.
Thank you, Professor Yogesh Singh ji, for those very kind remarks introducing me to the participants. I would like to start by expressing my grateful thanks to the National President, Bharatiya Shikshan Mandal, Dr. Sachidananda Joshi ji, Organizing Secretary and my friend Sri Mukul Kanit ji, Joint Organizing Secretary Sri Shankaranand, and Director General of Research and Resurgence Foundation, Dr. Rajesh Beniwale, other distinguished members of the organization, and the erudite members. I would like to thank the organizers, and in particular Mukulji, for asking me to come over and give this talk. Of course, physically I could not be present with you, but more importantly that he wanted me to share my thoughts on an area where I would be interested to share this because of the type of responsibility that it carries. Of course, we did discuss the various possibilities, including the national education policy. But Mukulji was very keen that I go through India's space program, how it evolved, and what kind of challenges is posed, where do we stand today, and how do we want to go further. So I thought it's a very good suggestion. I took it up and gave this title of Reaching New Heights in Space, the Bharat's Way, because India's uniqueness in space is not only because it has successfully done many of the activities of space through its own engineering and scientific expertise, but more importantly, I should say it has a very unique place in the development of this country with applying the capabilities of space for a variety of purposes. That is what I want to bring in to the audience here in this connection. I was just going through the Bharatiya Section Mandal's role and the kind of things you are involved in. I should compliment you, all of you, especially the organizers here and others who created this system. It's a wonderful idea to create an enlightened India where Indian knowledge, traditional and Bharatiya Samskriti will be the guiding lights for making this country play its rightful role in the 21st century. So I think there are several ways in which the noble objectives of this Bharatiya Shikshan Mandali is taken forward by the organizers and other planners and actual ground workers. And when I was asked to talk about space, I was really enthused because it does fit in with the broader perspective in which Bharatiya Shikshan Mandali tries to develop India with various types of capabilities which we can be proud of. And India's capability in space, as I told you, and we will see it a little later, has resulted in most advanced technologies. And what is more important, these advanced technologies today are used at the grassroots level for various requirements of the people and their welfare. That makes the ISRO's program very unique anywhere in the world. And that's the story that I want to speak to you today in this connection. I will start off with how it all began, because as you know, the space, if you in one sense in the modern context, if you look at the space, it was started, if you say, in 1957. There was a first launch of the Soviet Union's Sputnik 90, I think October 4, 1957. That was the October Revolution, as you know, the erstwhile Soviet Union. And it was closely followed by an American launch, a Vanguard launch in 1958. So they were very close in trying to achieve the access of this vantage point of space. If you carefully look at the history and also the then situation politically, it was quite clear those were the years of Cold War. So obviously, military objectives were quite critical in the context of acquiring and mastering many new technologies which could serve that purpose. There were also the question of the space, which can provide a unique environment for looking at several aspects of the scientific studies, like the atmosphere, the ionosphere, the interplanetary medium, the sun, the planetary system. So there were this possibility of now opening up these areas by actual putting Indian man-made spacecraft into space. So there was a scientific objective, but at the same time, considering the fact that there was a Cold War, and therefore it became interpreted as a natural extension of this Cold War to a new domain. So that's how you look at the space in those years. That is where the America and the then Soviet Union came together and competed on one side and brought together an object from pushing the scientific objectives on the other side. If you look at the Indian perspective, if you really look at it, and there was an Indian, Dr. Vikram Sarabhai, who saw in this newly acquired capability of the humankind, that of accessing the space, as a new opportunity for this country. He thought this can really provide solutions to many age-old problems, whether it is in communication, whether it is in timely and accurate information about natural resources, providing information about meteorology, and then, of course, the areas of scientific research. So he saw in it that there could be several socio-economic objectives that can be provided for through the use of this technology. And therefore, he saw a new avenue which he knew India has to master. So if you clearly see this, here was an objective which was peaceful, which was directed towards a socio-economic objective, and a visionary like Dr. Vikram Sarabhai, who wanted to move forward using this capability by India also acquiring these kind of capabilities to use it, newly acquired vantage point of space for several of these kind of applications, which I will come back to you. So you can see the distinction between the two. And of course, by and large, you can see in some form or other it has evolved, and many other countries have joined this race. But also the military objective, the strategic objective does play a critical role in the use of space, even as we use this space for scientific and socio-economic objectives on the other side. What was Sarabhai's view on this? If you really look at it, Sarabhai was fully convinced, even as early as 3 to 4 years after the first Sputnik went up. There were people who were questioning why we should spend money when there is no clarity about its use, and there could be uncertainties, there could be risks, and there will be a lot of financial resources that it may demand in the coming years. So, with this kind of a thing, why are we pursuing this? So, that was the kind of question that Sarabhai faced. And in one of the United Nations talk, he said this, and which I would like to quote because it's so thoughtful that he said this. If we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. So that was his objective. And he was convinced that India should be able to be a leader in this and should be able to carry forward this noble objective using the newly acquired capability. So, how did it all evolve? I will now quickly jump to give you the totality of the picture that in the last 30, 40 years, the space has evolved before I go back to specific developments that took place during the era of Sarabhai and their illustrious successors. First and foremost, health today, we recognize that the national requirements in the area of education, health, connectivity, that is communication, broadcasting, and so on, weather, natural resources management, disaster management, and things and scientific research. All of them can be catered to. Now we have established capabilities which can serve to these kind of purposes. Now, in trying to go to this level of capability and capacity, we need to get step by step, very carefully learn the art of the game. And that is where we see the different era. The Sarabhai era, which was 1960 to 70, was an era of initiation. He had a vision that this high technology system has to be brought to the grassroots level and serve the country. So that vision he gave to the country. He created groups by which the scientific activities using space could be pursued. Then we learned the first step to how to manage a space system. It's not like the conventional systems of science and technology. There were uniqueness about it which had to be understood. So learning was the other part of it. Capability had to be built up. You need to bring engineers, scientists, capacity, industries, and so on and so forth. And also importantly, since we are the other countries like United States, Europe, and Soviet Union were catching up very fast with respect to the capabilities of space, there was also the possibility that we could work together through an international cooperation. So these were all the elements during his time. Dhawan, his illustrious successor, who succeeded Sarabhai after Sarabhai's untimely passing away in 1971, he did a lot of carry forward this and did a lot of missions where he brought ideas to do work and demonstrate tangible outcome of space in several areas which I just now listed. He created an end-to-end capability in the process, right from thinking of a mission to realizing the mission and then providing the services out of the mission. Prototyped many such, and he also mounted a research program to support this kind of an activity. And then came the fourth phase, with the more important phase, and which continues, which is called as an operational phase, which was done by both Dhawan and his successor, U.R. Rao. This is the era beyond 1990s, where we now have satellites which can provide communication support, television support, remote sensing support, and also do scientific work. So we have here a number of services today that the space provides, and that one can see clearly. The other, of course, is the global outreach also. We have a good cooperation in the international sphere. This was also broadly brought by Dhawan and subsequently UR. So you can see that the various dimensions of space has evolved, increased its effectiveness, and today it is playing a critical and central role with respect to the various uses to which the space can be put, with socio-economic objectives, as I mentioned earlier, in the context of bringing the space into a new method of development. Let me say a little bit about Dr. Vikram Sarabhai, because even though he was well known as a scientist, he was really basically, he comes from an industrial family. His parents and other predecessors, they ran various types of industries in Ahmedabad and other parts of Gujarat. And also, but then he had a very strong affinity to science. So he continued his studies in science even as he worked with industry, with the family which was industry oriented, and finally got a PhD from Cambridge in physics, in cosmic rays. He worked with Professor Blackett, who was a Nobel laureate. He worked with Sir C.V. Raman in Bangalore. He was another Nobel laureate. So you will see that he worked with some of the top-notch physicists of his time and then got his PhD degree. And when he came back and settled in India and started working with industry, this space became a very important development in the country and in the world. Here he dreamt of what space can do. And then he continued, he contacted the political system and also a set of people who are intellectuals like Professor M.S. Swaminathan, Professor Vikram, Professor Ramanathan, and many others who were people with a broad understanding of the type of role technology, MGK Menon, and I should say many of them have a broad understanding of how technology can influence the development of this country. So with them, he conceptualized this idea that we should move into the space program. And he created a vision and also took the first step. But what is also unique about Sarabhai, I've just put some photographs here. He started the physical research laboratory in Ahmedabad. That was the cradle of India's space program. He started with Ahmedabad Textile Industrial Research Association, which was a research center for textile kind of an industry. He had a role in the formulation of IIM, the Indian Institute of Management in Ahmedabad. He started National Design Institute, Community Science Center. So if you really look at it, he was a great visionary who saw the role of multiplicity of these kind of endeavors and new directions in the context of India's needs. And he built institutions around these ideas. So he was also not only a great visionary who gave space to this country, he was also an institution builder who built institutions for a variety of objectives. All of them today, I should mention without hesitation, that they all are doing exceptionally well and in tune with the times in which we are today. Now, what are the things that during his time, as I told you, he achieved? Of course, one of the important things I would mention that when he conceived space as an activity for this country, he saw that we have a very interesting geomagnetic resource, which is the science resource, which is at Tumba, a equatorial rocket launching station in the southern tip of Kerala, on the southern tip of India. There is a magnetic equator that passes through it. You know, they have a geographic equator, there is a magnetic equator. This magnetic equator triggers a number of interesting scientific phenomena in the atmosphere. So one of the first things that he thought is, why don't they take advantage of this location, unique location of a geomagnetic equator in Tumba, Tumba is nothing but is a flower actually in that part of the country, and it was the the place itself came to be known as Tumba, and it was called the Tumba Equatorial Rocket Launching Station. He started this rocket launching station, collected interest of geophysicists in the country and also abroad, and thus started a research program through sounding rockets at the modest beginning of India's space program. Certainly, he also knew that we have to work on the technology. We need to have our own ability to launch rockets, and most importantly, when it comes to satellites, it could be a strategic capability to launch them through a rocket, and therefore India should master the technology of rocket. He developed the satellite launch vehicle 3. I should say the project director for the SLV-3 was Dr. Abdul Kalam, whom we have put the charge finally in putting this SLV-3. Rohini sounding rocket for doing scientific experiments in Tumba. And then third element he brought in was that I need to explore and also demonstrate to the country that I can use the satellite communication for education and development communication. I can use satellite-based imaging system to look at the natural resources of the earth in a timely fashion. I should work with the countries abroad to bring their capability and our capability together to do this kind of application. So he originated these concepts. And then ultimately, he also made institutional mechanisms how to go ahead, because we don't have the culture of working with space. We need to create technologies, we need to create applications, we need to work with the users in the application, and then to work in an international mode, and then work with political system with respect to getting the necessary approvals and getting his vision sold. So there were a multiplicity of challenges that he faced with respect to bringing the space into the forefront of this country. So this was the central thing, and these are broadly the beginnings of how the space started, thanks to his original thinking with respect to science, technology, application, as well as institutional mechanisms and several related matters. I would, at this particular, leave this and go to his successor. You know, Sarabhai passed away in an untimely way on December 31st, 1971. And that he was hardly 52. But I think, as Sir C.V. Raman mentioned, that he was burning himself with the kind of work. So, in fact, once he told Sarabhai that you are burning your candle at both the ends. So, that is a kind of a thing. Obviously, by the age of 52, he was no more with us. A great loss for the country, but then it was so. And then he was succeeded by a very distinguished professor, aeronautics professor, Professor Satish Dhawan. He had a very distinguished but unusual academic career. He had a Bachelor of Arts in Physics and Mathematics, MA in English Literature, BE in Mechanical Engineering from Punjab University, ME in Minnesota in Aeronautics, and a PhD from Caltech in Aeronautical Engineering. So you can see the variety of things in which he went through an academic curriculum. And he was also a student of Hans Lippmann. And Hans Lippmann, I should mention, was the student of Theodor von Karman. And Theodor von Karman was the father of American astronautics. So he was the grand student of Theodor von Karman, Dr. Satish Dhawan. He took over the chairmanship of ISRO in 1972, and he stayed there for 12 years. And he was a rare confluence of different personality: teacher, research scientist, engineer, technologist, manager, leader, and advisor. And he was an extraordinary institution builder like Sarabhai. And you also mentioned that not only space, he was also associated with several other organizations. He transformed every organization towards modernity and more effectiveness. But I should say that he was also the director of the Indian Institute of Science, the premier institute for education and technology in this country. So what are the things that Satish Dhawan did during this period? First and foremost, he knew that we need to now start building, taking cue from Sarabhai, that not only Sarabhai demonstrated that we can have satellites and it can be used for applications like communication, broadcasting, remote sensing. So we need to build our own satellites. So he started building India's first satellites, and he initiated this program called the Aryabhat. Aryabhat was the first Indian satellite to be built and launched. But this also was triggered by the then Soviet Union, who suggested that they could help us to build the first satellite and do it faster. And then the government saw merit in this. So we worked with the Soviet Union, but the Aryabhata itself was designed and built in this country. and it was launched in a record time of something like 36 months. So that is a remarkable feat considering that we had no benchmark and no experience with Bharat. And that was quickly followed by an experimental remote sensing satellite. If you could build a satellite now, Aryabhat, which is technology demonstrator, why can't we now convert that capability to a more tangible outcome like remote sensing from space to look at the Earth resources survey? So that was the genesis of Bhaskara, and we built Bhaskara during his time. A number of technologies he initiated. First and foremost, he knew that if we have to expand the objectives of Sarabhai's vision, we need to create a larger space infrastructure. So he started building instruments at Vikram, infrastructure at Vikram Sarabhai Space Center, at Bangalore, the ISRO Satellite Center, at Space Application Center at Ahmedabad, and then Sriharikota Center to launch the satellites. So he started creating this huge space infrastructure during his time. And also then he knew that we need to move towards a launcher. I told you that it's a very strategic item. Nobody can transfer technology for the launcher. And therefore we have to be self-reliant in this. And this self-reliance essentially means that we can launch our own satellite without depending on others. So that is where the polar satellite launch vehicle configuration he gave to this country, and also a more advanced launch vehicle called the GSLV, geosynchronous. Initiation of a program on an advanced cryopropulsion. I won't go into the details of this. And then he shaped the Bhaskara, as I mentioned, Apple, which is a communication experimental satellite. And then he also decided, even though Sarabhai had already conceived this, that we need, depending on the type of experiments we did in the earlier times, using the satellites which we got from America, we found that we need to have communication-based, satellite-based communication in this country as early as possible. And the timeline that we need to put within our own country to realize this, we found that it is much, much longer than the time we need to establish a satellite-based communication. So he made a major decision of buying the first 4 satellites from abroad, and then decided that the very process of buying, we also can build the second generation and third generation of INSAT. There is a very strong, very interesting strategy that he developed, and which is also a very key strategy even today ISRO follows. And then we had the indigenous ISRO INSAT 2, as I mentioned, and the Indian remote sensing satellite. Indian remote sensing satellite, unlike INSAT, we decided to build in India simply because they are camera systems. And camera systems in space, again, has a very interesting strategic capability to look at other countries. And therefore, nobody shares you the technology. So we need to build our own satellite. We need to build our own cameras. Applications, he pushed the application to demonstrate how communication do developmental education, for example, education, environment, agriculture. There are many areas in which you need to teach the masses, teach the local people in rural areas particularly. So how do we do that? That is where the satellite instructional television experiment using an American satellite was conducted. We also did an experiment where the Apple, the India's own communication satellite, was put into a application in the communications and broadcasting, and used American satellite to prove many concepts of a remote sensing where we can get timely, accurate, and precise information about natural resources. And IRS definition, that India's foremost and very prestigious remote sensing satellite, IRS, was defined during his time as to what it should be by working closely with the various stakeholders in the country, and ultimately the association of sector. The most important thing I see is that he institutionalized the space. Space has to be made sure that we have a sustainability for space. Sustainability for space means that we need to have people who use the space capability outside ISRO. So that is where he created what you call as an institutional mechanism. He created the Space Commission, which is the topmost body to oversee the India space program, and headed by the chairman of Space Commission, but contains some of the topmost functionaries of the government of India. And then you have the institutional mechanisms like the INSAT Coordination Committee, Remote Sensing and Apex Committee, Science Apex Committee. These Apex Committee were primarily users who would use the space system. And so they came together periodically along with ISRO to define how the space system had to be configured and delivered for their use. So it really became a very beautiful way in which the various users, both in the government and now with the private and public sector have come together to define what is needed out of the space, and we build the missions like the satellites and the corresponding launch vehicle, carry out the launches, and then also operate the satellite as per the requirements of this. So this is the beautiful way in which the entire thing was structured, and we should owe much to Professor Satish Dhawan about his thinking to create this kind of an institutionalization. The third pioneer of space was U.R. Rao, who succeeded Satish Dhawan, who was the chairman for nearly more than a decade. And so U.R. Rao was a student of Dr. Vikram Sarabhai. He was an expert in cosmic rays. He took his PhD from the Physical Research Laboratory. I also did my PhD there. And postdoctoral work he did at the Massachusetts Institute of Technology and other institutions in the United States. And he also worked in areas like some of the very pioneering programs of planetary missions in US, like Pioneer 6, Pioneer 7, and interplanetary missions. He worked very closely with some of the topmost planetary scientists in the United States. And he took over after the stepping down of Chairman ISRO, Professor Dhawan, in 1984, and he was the chairman of ISRO for the next 10 years. And I should say one important thing about him, and he was really the father of the India's satellite program. I said that the Aryabhatta, which is Satish Dhawan initiated, the entire thing was carried out by U.R. Rao. And I also said that at 34 months he completed, 40 months he completed this task, which in a sense could be a kind of a record simply because we started from a scratch. We had to know the technologies of satellite, whether it is a structure, thermal, power, control systems, electro-optical system, integration, mission management, orbital mechanics, control system. So you look at it, and also you need to build up the capability in terms of youngsters who come together in a teamwork to do. You need to create institutional mechanisms of working closely with the industries, and then ultimately even with the educational institution. So there was a whole host of things which has to be established, but which had to be learned also, because we are doing the first satellite. And we worked with the Soviet Union that time so that they can launch this satellite with their own rocket, because we didn't have a rocket. This satellite weighed something like 350 kilograms. So it had to be launched with at that particular point, 1975 kind of a time frame. It had to be launched with the Soviet Union. But then the Soviets were the ones who were willing to do this for us, and we got it launched. But the important thing about UR is the fact that he did the first satellite and build the satellite capability in this country. So what are the things that highlight? I'm only giving the highlights here. They have done much more than what I say here. He created a full-fledged capability to build satellites that become the basis of all satellites. When I say satellite now, I'm talking of satellites for communication. I'm talking of satellites for broadcasting. I'm talking of satellites for the remote sensing. I'm talking of satellites for the navigation. I'm also talking about satellites for scientific purposes and so on and so forth. So one is talking today, but the generic aspect is the satellite bus. And right, you build this kind of INSATs, IRS, and so on and so forth. So the basis of building this and capability to build this is the one that you are laid for this country. Remote sensing application, he put also, because ultimately, even for using by the users, they were finding it as a new tool for their own application. So we had to work closely with the users in the country. When you talk about remote sensing, we work with agriculture people, we work with environmental people, we worked with remote sensing, water resources people. So there were a number of earth resources with which we had to work and tell how satellite pictures can be used for that, the process of image analysis, image interpretation, the deriving the quantitative estimates of the remote resource and getting in a timely fashion. So these were the challenges of trying to introduce this new application using a new technology like remote sensing. So he worked very hard with the users in various ministries of the government of India. Similarly, he also did quite a lot of work in taking the PSLV to its final stages, even though he did not succeed during his time in the first flight. There was a small anomaly, but the completion of the activities related to the polar satellite launch vehicle, which puts the satellites into the polar orbit and primarily used for remote sensing purposes, those kind of satellites. And he also initiated the work on GSLV. And as I said, remote sensing and communication satellites and their application on the sociological front. He worked very closely with the agencies of the government of India and created mechanism to do this. Besides the institutions with Professor Dhawan himself had created for this, like the National Natural Resource Management System or the India INSAT Coordination Committee or Advisory Committee for Space Sciences and so on and so forth. So there is a, this is to give you a flavor of how the third of the pioneers did this. I am saying these three in order because I think each one of them, one for the first one had a vision, the second had a vision and a mission, and the third one was intensely mission oriented, and he wanted to move it further. So between the three, they formed a beautiful step, one step next to the next, and so on. And I think ISRO is, in a sense, very fortunate that we had this kind of three leaders who tried to give the initial start for this. And initial startup was so good that we have been able to keep that momentum so far. And you are seeing for yourself in the coming in the later years what ISRO has done. So if I were to summarize until now what ISRO has done, we have a good number of success in terms of our polar satellite launch vehicle record. We have something like 46 launch after the 48 launches we have done of the polar satellite launch vehicle. We had 46 launches, one of the world's best records that we have on the PSLV. And our budget, of course, has grown from a few hundred, from few crores to few hundred crores to few thousand crores. Today it is $1.7 billion. This is one of the decent budget for any space program anywhere in the country, and we have been getting support from all the government. And particularly, I should say, this government has put much more resources because they want to bring in the human space flight as another important component of which I will quickly draw that. Then, as I said, that we have also created in the process the utilization of these satellites or the space systems, and that is the application leadership. And India is one of the strongest application leadership anywhere in the world using space. And in the case of satellites, we have built something like 109 satellites have been launched, and there have been an enormous high level of success, like in the launch vehicles. One of the important things that we have made sure was the self-reliance. As the present Prime Minister often talks that we have to be self-reliant in this country on many matters. This is something we have tried to pursue, even though it's very challenging in the case of space. And the state-of-art technology we always look for. And that's why our satellites and launchers are all Indian. There is tremendous Indianness about it. And then there is the industry. We have brought in industry into it because we know that many of the things have to be produced, they have to be fabricated, they can be assembled, they can be tested in the industry once you have all the details. So we have tried to grow the industry. In fact, I should say 50 to 60% of the budget that goes into the launch vehicle program is now given to the industry. You take up about 50% of the budget of the satellite that goes into the industry. So you have already a fairly large investment into the industry. And in the process, the industry learns the art of space, it learns the art of perfection, quality control, reliability, and so on. And this upgrades the industry also. So you can see the dual purpose in which industry can be brought in. We have also a very good cooperation with the world. So we have a global role. We have more than 50 countries with whom we have agreements, and we work very closely, either working together for a satellite program, working together for launching, working in applications and things of that kind. And currently, of course, within ISRO, we employ about 1,800, 18,000 people, but you have a similar number or even bigger working in industries or another institution. And we have as I mentioned, we have we have a global role. I said 50 is a role. We have also started a level of commerce, and I will say a little bit about the space commerce later. And more recently, thanks to the Honorable Present Prime Minister, we have initiated a program on the human space flight, and ISRO is working furiously to meet the kind of schedules that he has laid down, the Honorable Prime Minister has laid down in trying to have the first launch by 2022. And infrastructure we have created in the process, not only within ISRO, but outside ISRO on an end-to-end basis. So it gives you a snapshot of what has happened in 50 years, and much of it comes out of the three pioneers about whom and what they did. You got a feel of it as I went ahead. Now, to summarize what I just showed in a little more focused way, I would say that there are five major programs of ISRO today. If you want, there are many other things, but I'm just saying the major ones. We have one, communication, broadcasting, and navigation. When you talk of communication and broadcasting satellite, These are normally a geosynchronous satellite, a satellite which is perched at 36,000 kilometers above the Earth's equator. And the importance of this kind of a orbit is the fact that it has a revolution period at that particular orbit of 24 hours. Now, if you take the Earth's rotation period, it's also 24 hours. There is a synchronism between the Earth's rotation and the revolution of that satellite in that orbit. So you have a relative stationarity between the satellite and the ground and a ground point because of these geosynchronous characteristics. So all the geosynchronous satellites are first at 36,000 kilometers, and that is where we work on the communication satellite, broadcasting satellite, and to some extent the navigation satellite. Communication today is used for telecommunications, television, telecommunication, very many other types of VSAT, very small aperture terminal communications, or radio to broadcasting, and many other kind of things. And so far as broadcasting is concerned, television is one of the key elements. Besides that, we are also using it for sociological purposes like telemedicine, tele-education. So there are all the various things on which today communication and broadcasting satellites are used. And we have a fairly comprehensive set of satellites operating in various frequencies of communication. This is extremely important because the frequencies of communication is something which is a very sought after resource at those altitudes, because otherwise they can have interference between different satellites of different countries. So you need to have really vie with each other to get the count. We have communication now focusing on frequencies of S band, so extended C band, extended C band, KU band, KA band. These are all the various bands of frequencies, and these are increasing at higher and higher frequencies. And when you use higher frequencies, you get a better bandwidth and therefore better communication capability. So these are the, I don't want to go into the details of, but what I want to say is the India today has communication satellites which work on multiple frequencies, right from the S band to some of the highest frequencies today used anywhere in the world, beyond K band also. So just to give it. Similarly, we have also developed now a navigation system. It is the regional navigation system, which provides you position, location, and many other applications to which it can be used, including strategic application. The other area is the remote sensing. I said about the remote sensing satellites, they are very unique. India has produced a constellation of remote sensing satellites. And I should say that over the years, right from the Bhaskara, which was the first experimental remote sensing satellite, what a remote sensing satellite does is that you develop a camera. That camera, you place it on the satellite, which is a platform, and the satellite has all the other supporting elements like the control system, power system, and the communication systems, and so on. The camera takes a photograph as it moves to different parts of the earth, and these photographs are digitized and then transmitted. And on the ground, we try to process this with respect to image processing, analysis, interpretation, and other techniques. And so you have the picture of what the picture was taken by that camera on the ground. And you can have high throughput, and a large area can be snapped in quick succession. So this is a very useful and enormous capability that very few countries in the world today possess. And India, I should say with pride, is a leader in this area of remote sensing, with having built some of the best satellites in the world. And even today, we lead this in terms of optical remote sensing in the optical domain, optical wavelengths, remote sensing in the microwave wavelength. The advantage of a microwave wavelength satellite is the fact that you are not bothered with the light which is needed for optical remote sensing. So you need a solar radiation. In the case of the radars, which is used in the remote sensing, they can use their own energy to return and then get the pictures. So there is other kind of a thing. Then there are many other things like hyperspectral systems, high resolution systems, cartographic systems, and things of that kind, resource system. So India has a variety of these capabilities. They meet the requirements of the various application, and application, I should say, is a fairly vast area where many government departments and also private agencies work in the use of remote sensing satellite pictures. This includes agriculture. Agriculture, we try to get timely information about agriculture by continuously monitoring the growth pattern of an agriculture. We can even look at the present water stresses and other kinds of abiotic and biotic stresses, and we can take corrective actions in this. And then also we can do the land reclamation and wasteland kind of a thing so that we can increase the productivity. And then we have the environment, forest, biodiversity. We have the water resources, both the groundwater exploration, surface water mapping. These are today done very routinely by the satellite system. Then you have the ocean, the actual, you are looking at the ocean, coastal regions, and also look at the schools of fisheries. Tremendous capability to identify schools of fishing where the fishing boats can be directed, so there is an operational capability for this. And then atmospheric sciences. So if you really look at it, there are very large segment of uses in the earth resources, both the dynamic as well as static resources, where geology, for example, is another area, geological prospecting. So you can see that there is a tremendous use of these in a number of departments of the government and also in the private agencies. And India has some of the best satellites in the world in trying to do this. I would say about space transportation system, I will come to that little later. And so also Gaganyaan. Space science is another very interesting area. We need to promote science. We started with science in the Tumba when we wanted to study the atmospheric sciences. And then today, science, space science is one of the key elements of India's space program. On one side, it advances the knowledge and it caters to a large number of scientists in the country who create new ideas and new knowledges. On the other side, they become a source of inspiration for the younger generation. And third thing is that they also demand high technologies in terms of the requirements of a space mission where science is asked. So we have a upgradation of technology that comes in. So these are many things that can happen. And so space science has really supported us in many ways. So you have this kind of a thing. So you can see, even though I put it in a very small slide, there's a very large effort that goes on in this country with respect to the use space system creation, space system utilization, and ultimately giving it and getting feedback for futuristic planning and more advanced systems. Just I said about the space science. I will go from the regular space science to the planetary exploration, which is a more recent entrant into India's space science program. One of the important things we decided was that having already built various spacecraft, various satellites and capabilities to launch, we decided that we should really go one step ahead of only learning about Earth and its environment or a little bit about the solar system. So what is the next? So there was a country's discussion, and the discussion in the country ultimately led to the fact that we should enter into the era of planetary exploration. I want to say this because moon is, of course, was identified as a target, is the closest object to the Earth, and therefore could be a mission could be undertaken. We have the capability of PSLV, GSLV to accomplish the mission as a launch vehicle. We have the satellite capability built to IRS, INSAT, and many other satellites, so we can create a spacecraft. And then we have a number of scientists in this country who are interested in planetary exploration and planetary science. So the first of them was planned, and I should say that Vajpayee gave the go ahead for India's planetary program, and he said that it should not be just a one mission; it should be a mission of a future. So when we submitted to the Vajpayee the Chandrayaan, the Mangalyaan name, he converted that into Chandrayaan and he called it Chandrayaan 1. And he clarified that I call it Chandrayaan 1 because I don't want this to be a single mission, it will be a series. So you can see the kind of vision that he had when he tried to open up planetary exploration for this country. So we have from there, we have gone into Mangalyaan, a more advanced satellite, a spacecraft, which went to Mars. It is a 300 days journey to the Mars. It takes, once you reach Mars, it takes, I may say, 12.5 minutes for the communication to reach you. So you need many ways of dealing with a problem in the spacecraft because you can't just send a message. You have to wait for 12 minutes for it to reach there. So you need autonomy, you need robotic systems and decision-making system on board and so on and so forth. It's a fairly advanced system besides scientific instruments that are there. Like in Chandrayaan, it studied moon surface, it looked at moon geology, looked at water most importantly. And I should say that Chandrayaan 1 is one of the first spacecraft to detect water, which is one of the key elements for the use of moon in the coming years. either as a platform or as a settlement and so on. So Chandrayaan 1 was one of that. Here was another Mangalyaan, which also India mastered the art of putting it around the Martian orbit. And most it's, of course, as I mentioned, it's about 300 days it took, because you are talking of a 1.5 astronomical unit distance it has to traverse, your long communication times. And so we try to take some very modest scientific things, like trying to look at the surface of the Mars, to look at the methane, because the methane is one of the important indicators for the life, and then look at the alpha areas like Lyman alpha, the ultraviolet radiation, which will give you some idea about the deuterium and hydrogen in the very critical in terms of the Mars evolution. So these kind of things are science has been studied with Mangalyaan. Chandrayaan 2 was supposed to land and put a lander and the rover. It went up to the 100 kilometers and very close to the moon. In the final art, of course, we had to give up because of certain anomalies. But as an orbiter, it's producing a whole rich information about the moon and the surface, which will be used not only by the Indian scientific community, but by the international community in understanding the moon and its origins, and which will have a lot of bearing ultimately for the exploration and exploitation of the moon. And currently, of course, ISRO is working on several other kinds of planetary missions. Maybe a mission to moon, Venus could be a possibility, and also looking at asteroidal missions. So there are many other interesting things, not only in the context of using the scientific community in this country and also being a part of the global cooperation, but equally importantly, the younger minds and also the challenge in technology. So there are several dimensions to this, and I'm very happy to say that India ISRO Space Science Program, and particularly the planetary program, is certainly moving in the direction which can bring a lot of pride for this country. I'm only, before I give away the space science part of it, I only want to talk about one satellite that was launched a few years back, about 5 years back, I should say. This is a satellite for astronomical observation. And this particular astronomical observation was to look at the objects in the sky, like neutron stars, black holes, galaxies, quasi-stellar sources, and things of that kind, and to look at their characteristics with high-resolution detector systems. So AstroSat carried 5 or 6 detector systems, which were built by some of the foremost institutions in this country, the Tata Institute of Fundamental Research, Indian Institute of Astrophysics, ISRO's satellite groups, and so on and so forth. And they built this, and it has been now working for 5 to 6 years. And I should say some of the very startling results on the science has come out of this. This is the satellite which you see on one side, but equally important, I want to show the type of images it has returned about a galaxy in the ultraviolet. You can see the details that you can see on your right side. And the same object was seen by the American best ultraviolet satellite, the Galax. You can see how the Indian satellite's clarity does the image. I am emphasizing it to say today, among the operating ultraviolet astronomy satellites in the world, today AstroSat is the best in the world. So just to give you that feel, I thought I should do it proudly by showing you this. And of course, now there are, uh, uh, I will go to the other major area, which is, as I told you, the launch vehicle development is one of the key elements of ISRO's program, primarily because they're strategic and we need to master this. We have moved from polar satellite launch vehicle to GSLV Mark III. I have put down the numbers at how much of tons it can carry into a geosynchronous launch. I won't go into the details of that. Currently, ISRO is under development of a semi-cryogenic engine, the fourth one you can see from the left, and this can put a 6 ton into the geosynchronous orbit. The present capability of ISRO is about 5 tons to go into the geosynchronous orbit. But what is important to note that we have covered most of the requirements of our own heavy satellites to be put into the orbit, whether it's geosynchronous or polar or near Earth orbit, by means of these vehicles. And also GSLV Mark III has been chosen for flying the India's first manned mission. So that is also there. It is now being proven and being managed. What is important is we need to go for more advanced space transportation system. One of the key elements of an advanced version of a space transportation system is to have a reusable launch vehicle. Yes, and now currently these vehicles that you see here, the four of them, they are all what you may call as expendable launch vehicles. You have it goes into the orbit and comes down because it is not usable. None of the hardware is useful. On the other side, the one that we are thinking of a reusable launch vehicle, we have done a first or second test successfully. It's a fairly complicated thing with respect to hypersonic flights, control guidance and navigation using its autonomous capabilities, and then simulations, aerothermal modeling. So there are many other kinds of technology that comes into picture. I can say with pride that ISRO had done the first test in the recent years, in the last 3 years, of a prototype version of this, and they now plan to move forward. And in the next 10 years, we are sure that we will have an aeroplane-like concept coming down from the orbit and landing, and then again it can be get hot ready like what you see in the shuttle. So this is what ISRO is working today in this area. Another important thing I mentioned about the fact that the present Prime Minister and the government has decided to go for human space flight, a major effort with respect to human rating of the vehicle, the launch vehicle. I mentioned about it. We need to develop crew modules, life support systems, emergency response systems, modeling systems, human mobility system. We need to develop simulations. You need the astronaut training. The whole set of things that it opens up. It's a fairly large amount of work, new types of work, new challenges are there. There's a new center which is working on this in ISRO, and ISRO is now going for a real challenge of meeting Prime Minister's target of 2022. Yes, that we would like we to have a human Indian human going into the space within this time. So this is something which is very challenging, and ISRO is taking up, and I see that they are moving well with respect to the various activities that is going on. I will just now try to conclude this with a few statements. ISRO also, because of its capability, has found a lot of interest in the outside world, even trying to commercialize our capability. If you really look at the global space economy today, it's something like 415 billion. If you look at India's space economy here with respect to that, it's about 2%. Public expenditure is showing 0.5%. So you see that we are putting targets which are going to be more like 10% for the India space economy, and also public expenditure to something like 0.2%. And what is the important thing is to have a commercial component of this. And the industries have to play a more total role, like satellite ownership, new services, overseas marketing, R&D. So why I brought this today in presentation is recently our honorable finance minister mentioned that we would like to go move towards private operations of the space, and we need to really work out the mechanisms to do that as we use the space capability also for the national purposes. We should be able to market it through private systems. So they should have the necessary regulatory approaches, which also have to be kept in mind, use of government-owned facilities, priorities and incentives, risk coverage, government procurement, technology cycle. So there is a whole host of things. And I'm happy to say that government is positively looking at this entire thing because it has come from the present government to make sure that we move towards a new direction of doing space activity in this country. You are certainly ISRO will have its role, but also there can be a private component which will then enhance and scale up many of the activities and bring in more revenues through privatization. And there is a corresponding requirement with respect to national space legislation. I won't go into that. When you have this kind of arrangements, the private operations, international regimes, and so on and so forth, obviously we need to bring in legislation. So I am sure that ISRO is working in this area with respect to the various aspects of what should be the legal structure for conducting the space in India, none also keeping in mind the international regimes and our interface at the international level. Now, just to move towards future, there are many things that are possible today in the next 50 years. For example, ISRO will be working on a new astronomy satellite. You saw AstroSat, a more advanced version, environmental science. There is also work going on in the planetary exploration side. And you saw the Mangalyaan and the Chandrayaan 2. It could be Venus missions, it could be asteroidal missions, and maybe even things like Enceladus, Titan, and some of those kind of moons of other planets. And then very interestingly, ISRO is also working on a satellite that would be searching for life in other planetary systems. Currently We have planetary systems outside our solar system, and these planetary systems have been discovered around other suns. Something like 4,164 exoplanets have been discovered, and therefore, what ISRO plans to do is to pick up many of these potential locations for the life to evolve in the planetary system, send instruments which will look at the various aspects of the atmosphere, its composition, its evolution, its dynamics, and things of that kind, and try to withdraw from that conclusion with respect to how whether there could be life in those planetary systems. And life needs a very special ecosystem. So our Earth is located at a particular point with respect to the sun. So if the Earth has been located, if, for example, nearer to the Mars, then we would have had one set of problem. If it has been located nearer to the Venus, we would have other type of location. So it can just be located with respect to its parent sun at a very clear-cut location. So these are the tricky things, but I think the discovery is now going furiously, and India will certainly be a very important nation working in this area on its own as well as through international community. I just want to future. Can I show this? I'm just trying to show here the future human's perspective. You saw a city, you saw a conglomeration here. You see the state of Karnataka, how it looks like. I'm looking at the different perspectives of the space. You look at India from space. Then you look at the globe, our own globe, sitting a little further away. And this is how the Earth looks like if you sit in the moon. Now, if you now look at the Earth from Mars, you see it becomes a very small spot there, and from the Saturn rings. And there are one more. You can see, therefore, the perspective of space, as perspective of the Earth, planet Earth, from space changes as you go more and more ever. And we become, even from Mars or Saturn ring or this thing, one can see Earth is only a spot. So this gives you a feel of how the Earth should be seen as an integrated entity. And even though we may create geography, we may create political boundaries, we may create economy which are different in different political systems and so on and so forth. Ultimately, space puts you where you should be. The perspective of space, of Earth from space, which shows you that you are an integral point in the sky, and you have to see yourself in that context. That's a very nice way to convey the importance of the humankind in the overall scheme of things. I only want to conclude by saying a key imperative to fulfill the dream of our Honorable Prime Minister making Bharat today to truly Atmanirbhar is transform our nation into a 21st century knowledge society, realization of which could call for successfully conducting mega programs like space missions that place highest demands on the intellectual and professional abilities of individuals, institutions, and nations. Thank you.
Thank you very much, Dr. Kasturi Rangan, for such an informative, useful, and meaningful talk. We are proud of you and proud of ISRO achievements. Every Indian takes pride in the achievements of ISRO. Dr. we have received many questions, but due to the shortage of time, we will not be able to accommodate every question. But I would like to ask two or maximum three questions. The first is, ISRO, first question is, ISRO is governed by scientists from top to bottom. Even in the department, there are scientists at the top policy-making positions like secretary, joint secretary, etc. Can you say that this is the secret of efficiency of ISRO? Bharatiya Shikshan Mandal is advocating the same in the education also. What are your views on that? You are the architect of new education policy also.
Yeah, ultimately we have found that areas where the decisions have to be taken, and in the case of ISRO, much of the decisions are related to the areas of science, technology, policies related to them, and so on, strategy, and so on. And there may be financial implications and other kinds of administrative implications. We have brought a nice synergy between the requirements of the space as seen in its core requirements, like science and technology and applications and users and international things, and how some of the requirements are also a part of a governmental structure and a system, and therefore we need to go through a bureaucratic approach. We have tried to do this. In the creation of a headquarters as a structure, for example, where you have an administrative setup with the scientists, and you have also the regular DOS setup with the bureaucrats, and they work closely, they consult closely. And even during my time, I would always make sure that we have the bureaucrats attending many of the reviews, technical reviews, which is normally said, "Oh, this is not my job. That is, you come only for money." It's not so. They should understand the reason for the money by sitting in the review and what is this. So this kind of culture, attitude, and I should say, during my time, I had some wonderful bureaucrats. We cannot say that they add substantial value to a component of a decision making, but only as a part of a total, not by itself a decision making. So that is all that you have to make sure. And I think this model is workable, and bureaucrats are certainly people who would like to support this kind of a thing. But I think
Okay.
scientists also, that's
Yes,
what I would
sir.
like to convey.
Yes, sir.
Yeah.
Next question is, in the Atmanirbhar Bharat Abhiyan, government declared that space research and other applications will be open to private sector and satellite launching in the PPP mode would be allowed. What do you think will be the effect of this opening up? Will it make it more commercial or will it benefit the nation?
You know, ISRO, the primary responsibility of developing technology and capability for use of space for applications, and also make sure that this is proliferated in the country to different segments of the other activities. So this is the main responsibility. The success of the ISRO is how well have you proliferated it and how well others are using it. Now, once you demonstrate this capability internally through a technology, through its development as a product like satellite and its utilization, I think that becomes a repetitive job for the subsequent missions. So that is the difference I want to make. So you do the main development, you do the main ideas, seminal ideas you create, and you have enough amount of resources for that kind of a thing. The moment you convert it to an operational capability, pass it on to somebody who can take it up and do it, continue, repeat it. So we see a very clear role for the private agencies and also public agencies who can take up this role of ensuring that they can enhance the role of ISRO by propagating what ISRO's capability is and making sure that is maximally used. And also they have much more flexibility for international commerce when it comes to selling India's products outside. Is we don't have to develop expertise for those kind of a thing. The commercial component of the private entities can do that. So I see a very concrete and very clear-cut direction in this, and with a good positive results. It need to be managed. There are questions of what I may call as a strategic nature, questions of security, the questions of policies and things of that. And nothing is unsolvable. This can be all done.
Okay. Last, very quick last question. Next, whether ISRO has ever taken help from Vedas in exploring the planets, including the probability of life on them. Please also throw some light over expanding universe. So, like, have you ever taken help from Vedas?
I don't, the question is, you work in a domain where you need a very strong base for mathematics and
I
science,
know.
and that strong base, the interesting aspect of Veda, because I also try to many times understand the thing. I think there are things that comes intuitively, and
Okay.
maybe some of the good intuitive ideas that some of us have proposed in our life, not only in ISRO or elsewhere, could be the product of our understanding Vedas. But
Okay.
you cannot say that it is Ada germinated. You know, it's quite possible you learn more, you understand more of a system. In fact, you know that in the national policy, education policy, you have suggested the question of a education which is holistic. The whole idea is if we can make the knowledge holistic at an undergraduate level, then that holistic education can trigger several means of thinking. Now, to separate out a Vedic inspired thinking versus non Vedic inspired is not the way to look at it. You have the knowledge and you have the ability to inspire with that knowledge, and that will have every element that you can amass. The better, the more in elements you have got, the better it is for you to think and make it much more precise. So whether Veda plays a role, Vedic thoughts plays a critical role or not is a different issue. But there are things which you do in life, which certainly, if you ask me, why do you do that? I don't have a straight answer with you.
Thank you, Dr. Saab. On behalf of Bharatiya Shikshan Mandal, I would like to thank you for sparing time for this wonderful and mesmerizing talk. Thank you very much. Thanks a lot, Dr. Saab.
Thank you very much. Thanks all of you.